Alright, my name is Mr. Fontenot, and this is Chapter 2 of the Instrumentation and Process Control American Technical Publications Textbook, Chapter 2, Fundamentals of Process Control. So as you can see here, there are 8 major topics in this chapter: variables, automation, control elements. You might want to make note that the most common final control element is the control valve. And maybe we'll show a picture of one of those here in a minute. Performance characteristics, control loops, common control strategies, instrument calibration, and instrument management software. Here is our objectives. We want to be able to define process control. We want to know the difference between automation and factory automation, process automation and factory automation. We want to be able to identify control elements of a process control system, compare static and dynamic performance. What is a control loop? What is a control strategy? Alright, what is a variable? A variable is a value measured by an instrument. Now there is more than one type of variable. There's a process variable. This is the variable that we are trying to control. If we look at the air conditioning system in our homes, what we're trying to control is the cold air blowing out of the vents. Next is a control variable. This is used to adjust the process variable. So with the example of our air conditioner system, this would be the coolant. This would be the freon. The freon is what is used to control the temperature of the air that blows out of the vents. And finally is the set point. This is our desired value, and it says an operator or engineer often determines a set point value. So we know that in our homes we are the operator and we set the temperature that we want our AC unit to blow at. And I've got some examples for you here in this spreadsheet, and you can find these slides on your Canvas page. So as I said, our home AC, what is our process variable? Is the temperature of the home. It's the cold air blowing out. Cold air of an AC system can only be 20 degrees cooler than the room air. So when you get in your car in the summer and it's about 160 degrees in there, your air conditioner is not going to blow out 60 degree air. It's only going to blow out 20 degree cooler than room temperature air. But as the temperature of the car cools down, the temperature of the air blowing out of the vents cools down as well. Alright, next is our control variable. As I said, your freon or refrigerant, that's what controls the air blowing out of the air conditioner unit, and then the set point is what we set our thermostat to. And I give some examples here for a heat exchanger and for a boiler, and you can read those for yourself on the slides that are linked to the Canvas page. Okay, you do want to write this down and make note of this. Typical examples of process variables are, now four of the most common ones are temperature, pressure, level, and flow. And what I want to show you with that is some details about our textbook. So let's take a quick look through our textbook. First thing I want to point out to you in the textbook here is that you'll see that part 1 of your textbook is about instrumentation. That's chapters 1 through 28. The second part, part 2, is about process control, which is chapters 29 through 52. This is the way your textbook's broken down. And it's broken down even further when we look here into temperature, pressure, level, and flow. So the four most common process variables are covered in these sections. Temperature, chapters 4 through 8, pressure 9 through 12, level 13 through 17, flow 19 through 22. So just something to keep in mind about the way that your textbook is constructed. So if you want to know a lot about temperature, you can go ahead and read ahead if you'd like here. Pressure, these chapters, these pages, level, these chapters, these pages, and flow. Now there's also, but not limited to, some other process variables such as humidity, density, and viscosity. And you should look those up and find out what those definitions mean. As I pointed out to you here, these are given large sections of your textbook. That's how important these process variables are. All right, our second topic in our chapter is automation. First thing that's mentioned is process automation. So when we ride by the plants here in the Lake Charles area, we see all the refineries or chemical plants, and we understand that there's processes taking place in there, and basically we're using a chemical process to, for instance, take crude oil and turn it into gasoline. Another example of process automation would be with bulk solids. Like here you've got some type of gravel that's being measured, and you would measure this by weight as it's flowing down your conveyor belt. The next type of automation is factory automation, and we would see this, for instance, Amazon shipping centers. They are keeping track of these individual boxes, individual packages, and this is the piece flow, individual pieces that they're referring to here. Some type of product here, this could be probably some type of liquid, maybe transmission fluid or something, I don't know, doesn't really look like milk, but alright. Also, the automobile assembly line would be another example of factory automation. Next is control elements. What is a control element? A process control system uses a primary element, a control element, and a final element. And they go into detail about that system here. This is what is known as a P&ID drawing. We're going to be studying these later. And with a P&ID drawing, you have these symbols here. Now this little triangle looking symbol here, these two triangles facing each other, that is a valve. But this little mushroom that's put on top of it, that is the actuator. So any valve can be turned into a control valve by adding an actuator. See, here's another valve, doesn't have an actuator, so it's just a normal valve, and this is a valve, and this is a valve, but this is a control valve. Okay? Okay, so here's a picture of a control valve. You've got the valve body down here, but we've added to the valve body the actuator, which is this piece here, and this allows the valve to be controlled with pneumatic air, and we can open and close it remotely with pneumatic air, and this is what a control valve is. Now you can tell by the color of this one that it's a Fisher, and these different colors will indicate different manufacturers. I invite you to do some searching on YouTube, and you could watch videos and learn about them. There's also some breakdowns of the different parts that you could find out about control valves, but we'll go into that later. Here's a good example. You can find a YouTube video on how they work. This TIC tells you that this is a temperature indicating controller, means it has a display on it. This is a temperature transmitter. Okay, so we can learn what all of these little devices are based on our abbreviations through our P&ID drawings. And in the back of your book there is a chart referring to that. Next is performance characteristics. Alright, it talks about static characteristics, or the characteristics of an element that describe the operation of the element at steady state conditionings when the process is not changing. And it refers to dynamic characteristics. And basically what this means is how fast it responds to a change in, let's say, temperature, for instance. So how dynamic it is means how fast it can change. So if you think about the old thermostat with the mercury in it that Mama would stick under your tongue and take your temperature when you was sick, you know, couldn't get to school, and that would kind of take a little time to get your temperature. But now we've got these ones I can just run across your forehead and get your temperature, or just even point it at you and get your temperature. Well, those are a lot more dynamic. They have a lot faster response time, and that's what this is talking about. So obviously the faster the response time, the better. And this applies to all kinds of instruments that we use in a process. Hysteresis is the property of a control element that results in a different performance when a measurement is increasing than when the measurement is decreasing. Alright, next we're going to talk about control loops. And here they talk about a control loop as a control system in which information is transferred from the primary element to the controller. And, you know, our controller in our AC example, again, is our thermostat that's on the wall. And that's how we control the system. And of course you have your final element and all of the pieces of your control system. Alright, next is common control strategies, and they go through on-off control, proportional control, where it's not just on or off, but here with a float valve you can have a lot of flow. If you're very low on water, you would have full amount of water flow coming in. But if you're about halfway full, well, you don't want full flow at that time. You want just a small amount of flow. And then if you go all the way up, well, your flow totally closes. We got one of these. Everybody's got one of these just like this in our homes, in your toilet bowl, in your toilet tank, in the tank of your toilet. And that's how it works. Got a little float valve on it. When you flush it, all of the water goes out, float valve goes down, opens the valve. As it fills up with water, a little float comes up, closes the valve. Alright, we've got a time proportional on and off controller. That's what this chart's talking about. It's going to be on 50% of the time, it's going to be off. Then it's going to be on and off, on and off. You can set your time intervals as you wish with a time proportional on-off controller. Okay, instrument calibration. Now, one of the things that you're going to be doing that's very important to a instrument tech is calibrating instruments. Now, let's say that an instrument is saying that it is, let's say 300 degrees in a certain process, but in reality, we know that it is only 275 degrees. Well, you've got to take your instrument and you've got to calibrate that instrument to make sure that you line it up with the actual temperature. Another thing that's very important is instrument management software. And this is basically just a database that tells you how many instruments you have, what is the history of the repair on these instruments. All of this is very important because if we want to know what instruments we have. We want to know how that we know if something went wrong with it, that it was properly repaired before it was put back in service. And obviously you don't want to keep all this stuff in a filing cabinet with a bunch of papers. It's a lot better to put it on a computer where everybody can access it. And it's called a database. And the world's greatest database is Facebook. You may not think about it, but what is Facebook? It's really a database, and we all put all of our own information in there. Think about it. Facebook don't even have to do the work. We do the work for them. We put our pictures, we put our names, we put our friends, we put everything. So anybody that wants to know anything about a person, you just go on Facebook and look it up. That's an example of a database. Same thing with instruments. Anything you want to know about these instruments, you just go into this instrument management software and you can look them up. All right. I hope you enjoyed this lecture. Please let me know if it helped you, and I appreciate you.